Assalamu alaikum. My name is Muhammad Ubaid Khan and this is lecture 1 of computer programming and fundamentals. Today I'm going to discuss a few topics like computers, how they work, about programming languages, etc. So let us start. First of all, what is a computer? A computer is an electronic device that processes data and performs tasks according to a set of instructions called a program. It can store, retrieve, and manipulate data to perform a wide range of functions, from simple calculations to complex simulations and data analysis. Computers consist of hardware components such as the central processing unit CPU, memory, RAM, storage devices like hard drives or SSDs, and input output devices like keyboards, mouse, and monitors, as well as softwares which include operating systems and applications. Computers work by taking input from input devices like keyboards and then process and manipulate the data and then show output. Computers can be categorized into various types, including personal computers, PCs, laptops, servers, mainframes, and supercomputers, each designed for specific tasks and scales of operations. They are used in virtually every field, including business, education, science, entertainment. The history of computers is often characterized into five generations, each representing significant advancements in technology, design, and capability. The development of computers has evolved from basic mechanical devices to modern day highly advanced systems. Let's explore the five generations of computers. Uh, First generation technology. The first generations of computer used vacuum tubes for circuitry and memory. Vacuum tubes were electronic devices used to control the flow of electrical current, but they were large and generated a lot of heat and were unreliable. Then second generations of computers, the second generation of computers used transistors instead of vacuum tubes. A transistor is a smaller, more reliable, and more energy efficient device compared to a vacuum tube. This advancement made computers smaller, faster, and more affordable. Then we had third generation of computers. The third generation saw the development of integrated circuits, also called ICs, which packed multiple transistors onto a single chip. ICs revolutionized computer hardware by greatly reducing size, cost, and power consumption while increasing reliability and performance. Then we had fourth generation. The fourth generation of computers was defined by the development of the microprocessor, a single chip that contains the central processing unit CPU. This innovation marked the shift from large mainframes and mini computers to personal computers, also called PCs. Then we had fifth generation of computers. The fifth generation of computers is characterized by the integration of artificial intelligence, AI, machine learning, and quantum computing technologies. While modern computers are based on microprocessors and integrated circuits, they are evolving towards parallel processing, neuromorphic computing, and quantum computing. AI and machine learning technologies allow computers to mimic human intelligence, learn from data, and make decisions. AI is used in applications like speech recognition, image processing, and autonomous vehicles. These days, programming languages are also used to make softwares, for example, healthcare softwares that people can use to keep their weight in check. For example, count their steps that they take daily, uh, and for other purposes as well. Uh, Computers are also being used in surgical procedures, and this technology is really helping advance the world and communication, making them an integral part of modern life. Then we have CPU or central processing unit, which includes CU or control unit, which fetches and decodes instructions, controls flow of information in and out of main memory, or controls operations of internal CPU components. Then we have PC or program counter, which points to the next instruction to be executed. Instruction register, which holds the instructions currently being executed. ALU, arithmetic logic unit, which performs all the arithmetic and logical tasks. Then we have memory and storage. Computer memory. Purpose: memory is used for temporary data storage while the computer is running. It allows the CPU to quickly access data and instructions needed to perform tasks. Volatility: memory is volatile, meaning it loses all stored data when the computer is turned off. Speed: memory is much faster than storage because it is directly accessed by the CPU. Types: RAM, random access memory, the most common type of memory used for active processes and applications. Cache memory, faster than RAM, it stores frequently accessed data to speed up CPU operations. Nowadays, cache memory is stored inside the processor itself. So, if a computer needs to execute a program, it first of all goes and looks inside the cache memory to find the program. If it doesn't find the program there, it goes to the RAM and then to the hard drive. Virtual memory, a portion of the storage, hard drive, or SSD used as an extension of RAM when the physical memory is full. Capacity, typically measured in gigabytes, with modern systems having 8 GB to 64 GB or more. Then we have computer storage. Purpose: storage is used for long term data retention even when the computer is turned off. It holds the operating system, applications, files, and user data. Non volatility: storage is non volatile, meaning it retains data even without power. Speed: slower than memory but offers much larger capacities. Types: HDD or hard disk drive, uses spinning magnetic disks to store data. Slower but cheaper and available in large capacities. For example, 1 terabyte to 10 terabyte. SSD, solid state drive, uses flash memory offering much faster read write speeds than HDDs. More expensive but increasingly common in modern systems. NVMe SSD, a faster type of SSD that connects directly to the motherboard via PCIe slot, offering even higher speeds. These days, SSDs are becoming more widely used, and people are not really using hard drives anymore because if the disks get damaged, you cannot recover any data from it. SSDs are expensive than hard drives, but they are more secure, they are faster, and they are not likely to get damaged while moving. External storage includes USB drives, external HDDs, SSDs, and network attached storage, or also called NAS. Capacity, typically measured in gigabytes or terabytes, with modern systems offering 256 GB to several terabytes of storage. Introduction to softwares. Without software, the computer is useless. Software is the thing that communicates with the hardware of the computer. Software developed with programming languages. C++ is a programming language which is suited for a wide variety of programming tasks. Before programming, it is useful to understand the terminology. Software. Software is a set of instructions that aid computer to perform tasks. Software can be categorized into two main types. System software manages computer like Windows 10, application software for specific tasks like Microsoft Word, Microsoft PowerPoint, etc. Software is vital in modern technology, driving everything from smartphones to computers. Then we have binary language. Computers only understand digital signals, zeros and ones. Language consisting of binary commands directed by the CPU. Binary digits, the digit 0 and 1. Binary code, a sequence of zeros and ones which is understood by the computer. Binary language is the fundamental language that computers use to process and store data. It is based on a binary system which uses two symbols 0 and 1. These symbols are referred to as bits, binary digits, and they form the building blocks of all data in a computer. Uh, a bit is the smallest unit of data in a computer and can be either a 0 or a 1. A bit is the basic unit used to represent information in the binary system. A byte is a group of 8 bits. For example, a byte could be 11001010. Bytes are commonly used to represent character Bytes are commonly used to represent characters, numbers, or other data in a computer. The binary system is a base 2 number system. Each digit bit in a binary represents an increasing power of 2, starting from the rightmost digit, just like decimal uses power of 10. Computers are made up of electrical circuits which can easily represent two states, on 1 and off 0. These states correspond to high voltage 1 and low voltage 0, making binary a natural choice for representing data. This binary system is efficient because it's simple and can be easily manipulated by electronic components. Byte. 8 bits are equal to 1 byte. This table shows the conversion of bits to bytes. 1 byte is equal to 8 bits. 1 kilobyte is equal to 1024 bytes. Like this, 1 megabyte is equal to 1024 kilobytes, and etc. Then we have assembly language. Assembly language is a low-level programming language that is closely related to machine language. The binary instructions that a computer's CPU executes directly. It provides a human-readable representation of machine code, making it easier for programmers to write and understand instructions for the computer. Assembly language is a low-level programming language that uses mnemonics, short human-readable codes to represent machine language instructions. It was also said that DeepSeek, the AI, was also made using assembly language. That's why it was optimized and it ran on even the lower versions of NVIDIA graphic cards, and it was equal in the performance of ChatGPT, Gemini, and other AI assistants. Each assembly language is specific to a particular computer architecture. For example, x86, ARM, MIPS. In If a program is written in assembly language in one computer, it will not run in another computer. We'll have to change the whole code itself. That is the reason high level language is more widely used, because any computer can run the code, and it is easier and effective and less time consuming than writing the code for every single other computer. It was very difficult for programmers to do that. That is why these days we use Java and Python and C++ like languages to do these tasks easily and efficiently. It is one step above machine code, which consists of binary or hexadecimal instructions. Hardware specific. Each CPU architecture has its own assembly language. Direct control. Computers have direct control over hardware resources like registers, memory, and input output devices. Efficiency. Programs written in assembly language are highly optimized and fast because they run directly on the hardware. Complexity. Writing and debugging assembly code is more challenging than high level languages like Python or Java. High level languages. High level languages are programming languages designed to be more user friendly and abstracted from the hardware, making them easier to read, write, and maintain compared to low level languages like assembly or machine code. They are closer to human language and provide built in functions and libraries to simplify development. High level languages are programming languages that use natural language elements, such as English like syntax and abstractions, to simplify coding. They are independent of the computer's hardware architecture, making programs portable across different systems. Examples include Python, Java, C++, JavaScript, and Ruby. Then we have C++. C++ is a general purpose object oriented programming language, also called OOP, that is widely used for building software that needs to be high performing, such as system software, application software, game development, and embedded systems. It was created by Bjarne Stroustrup. in 1979 as an extension of the C programming language, and it combines both high and low level features, making it versatile. C++ is a powerful, high performance, general purpose programming language that has evolved over several decades. It was made in the 1970s. Uh, the story of C++ begins with C, which was developed by Dennis Ritchie at Bell Labs in the early 1970s. C was a simple, effective, and flexible language that became widely used for system and application programming. C provided low level memory manipulation, which made it ideal for writing operating systems and embedded systems. C's popularity was the foundation for many programming languages and was used to write the Unix operating system. Uh, from the C language, in 1979, C++ was made by a computer scientist. Uh, his name was Vijarni Strastrup. He made it at Bell Labs as well. It was set out to improve C by adding support for object oriented programming, or OOP. OOP focused on encapsulating data and functionality into objects which can be manipulated and extended more easily. It had classes. The initial version of C++ was called C with classes, as it added classes, which are the cornerstones of object oriented programming. The goal was to preserve C's low level capabilities like direct memory access while adding more structured and usable code features. In 1983, the name C++ was chosen by Strustrup, as the plus plus is a C operator that increments a variable, symbolizing the idea that C++ is an enhancement of C. Algorithms. An algorithm is a step by step procedure or a set of rules for solving a problem or performing a task. Algorithms are fundamental in computer science and programming, as they form the basis of how we solve problems efficiently using code. In simpler terms, an algorithm is like a recipe for completing a task. Just as a recipe tells you how to cook a dish step by step, an algorithm tells a computer how to perform operations to reach a desired result. When creating a program, an algorithm is made first of all. It tells us step by step how the program should be made. Without algorithms, we won't be able to make flowcharts easily, and obviously, after that, we cannot easily make the program itself. So, algorithms are very important in a programmer's life, as it helps to identify problems step by step and tell us how the program should be made. Key characteristics of an algorithm. Input. An algorithm takes input, which is the data to be processed. Output. The algorithm produces an output after processing the input. Definiteness. Each step in the algorithm should be clearly defined and ambiguous. Finiteness. An algorithm must terminate after a finite number of steps. Effectiveness. The steps must be basic enough to be executed in principle with available resources. Types of algorithms. Number 1. Sorting algorithm, used to arrange data in a particular order, ascending or descending. Example: bubble sort, merge sort, quick sort. Number 2. Searching algorithms, used to find an element in a collection of data. Example: linear search, binary search. Graph algorithms operate on graphs, nodes, and edges to find the shortest path, detect cycles, etc. Example: depth first search, breadth first search. Dynamic programming solves problems by breaking them into simpler subproblems and solving each subproblem once. Example: Fibonacci sequence, etc. Greedy algorithms chooses the best option at each step with the hope of finding the optimal solution. Example: coin change problem, Huffman coding. Divide and conquer. Break the problem into smaller parts, solve each part, and combine the solutions. Merge sort, quick sort. Pseudocode. Pseudocode is a high level description of an algorithm or a process that uses plain language rather than programming language syntax to outline the steps involved. It's often used in the design phase of the software development to express logic in an easily understandable way. Pseudocode is not intended to be executed by a computer. Instead, it's a way to plan and visualize how a program will work. Pseudocode is a high level description, as said. It is the English language itself, you can say. Uh, Before an algorithm is made, the pseudocode is made for it. Uh, it tells the problems that could be faced by a programmer in making the program, and it outlines the steps involved in it. Uh, it can tell you how the algorithm can be made and how the flowchart can be made. It can tell you how the program itself can be made. Pseudocode is very good uh, for a programmer to know where they can have the problems and how to solve these problems. It tells the problems in a simple way, in a readable way, as said English, to know how they can be solved and how the program can be improved. Uh, Pseudocode is very important in programming. Characteristics of pseudocode: plain language, uses simple, readable language without focusing on syntax. Structured, follows a logical flow with clear steps. Algorithmic, clearly outlines each step of the process or algorithm. Language independent, it can be translated into any programming language. Flowcharts. A flowchart is a diagram that represents a process, workflow, or algorithm. It uses various symbols to show the sequence of steps, decision points, and other elements in a process. Flowcharts are commonly used in programming, problem solving, and system design to visualize the logic of a process or algorithm in an easy to understand way. Flowcharts are very important in programming, as we convert algorithms into flowcharts before creating programs, and it helps us visualize the steps that we are going to take to create the program. Uh, it can help us identify the problems, tell us where the conditionals are used, tell us how loops are going to be used in this program. Uh, it helps us make the process easy and simpler to understand, not only for us, for the user itself. If they want to look at how the program was created, it is a very simple way to let a programmer know how they should go through the whole process of making a program. It tells us the logical steps, the technical steps, and the way how the program should be made. Uh, Flowchart is very important in programming. Uh, these are the key flowchart symbols. The first one, an oval, represents a start or end point. Arrow. A line is a connector that shows a relationship between the representative shapes. A parallelogram represents input or output. A rectangle represents a process. A diamond indicates a decision. How to create a flowchart? To create a flowchart, follow these steps. Number 1. Identify the process. Understand the process or algorithm that needs to be visualized. Identify the key steps involved. Determine the symbols. Use the appropriate symbols for processes, decisions, input, outputs, and connectors. Map the steps. Start from the start symbol and work through each step in sequence. Use arrows to show the flow of control. Include decision points. When necessary, add decision points, diamonds to represent conditional branches. Finish with end. Conclude the flowchart with the end symbol. Example of a flowchart is shown. Here we start and take input of 4 marks. Then we take the average of these 4 marks and take out a grade. If the grade is greater than 50%, then they pass, and if not, then it outputs fail, and then it stops. Thanks for watching the video. I hope you all understood these topics. If not, please ask any questions in the comments below. Thank you. Allah Hafiz.